Hey guys, in this video I will be coding my SaaS platform for deploying reliable AI agents live. You will witness my entire process that honestly took me years to develop and that we now use daily to build large-scale SaaS applications like this, both fast and cost effectively. You will get an insider perspective on everything, including our architecture, our code structure, development principles, and more. So let's kick things off right away. If you want to know a full history of this product, just make sure to watch my previous video later. But in a nutshell, it's a platform built on top of my open source AI agent framework, Agencii Swarm, and it allows you to streamline your AI agent deployment process. Our long-term vision for this product is to allow anyone, regardless of their technical experience, to build a fully autonomous AI-driven agency. The main focus of this video specifically will be on multi-agent communication, which is one of the most requested features in our school community. Multi-agent communication is actually already there because it's the primary feature of my open source framework as well. So technically, all I need to do is just connect this feature with our backend, database, and frontend together so users can actually utilize it. So how I imagine this feature will work is we will probably have like another selector near actions here, where users will be able to select other agents that this agent can communicate with. And we actually already have a component like this. When you create a custom GPT, under agents, you can actually select multiple agents that will belong to this application. So let's jump into the code editor and get started on this. The first step will be to adjust our database structure. So we use a special shared folder here on the left, which essentially allows us to share types between frontend and backend. This honestly has been one of the most impactful practices that we adopted for building SaaS products because it allows our developers to ensure that they are aligned on specific features. So, for example, if a backend developer adds like a new type in a database or changes an existing type, the front-end build will fail if the front-end developer hasn't accounted for that change. So for this video, I will need to change the assistant document, which is essentially the configuration for our agents. It's still called assistant because, again, of the history of the platform, it started from an assistance API as a simple widget. But then I realized that there's more potential to this, and then we refactored our entire backend to run on my framework. So basically, assistants in our database are agents on front-end. And the type that I need to add is going to be called connected assistant IDs. So in this property, there will be other agents that this agent can communicate with. Additionally, I will need to change the functions types. So function types work the same way as Firestore types. Firestore is our backend database and functions is our backend API. So we also share request and response types for the backend API between frontend and backend. So for example, we have this create assistant request type, which is used by our backend API to create an assistant. And here I need to add another parameter connected assistant IDs. The next step in our process is to actually write a test. This allows our developers to really think through the feature before implementing it and catch any bugs early. Additionally, tests also serve as documentation in our applications because, again, through tests, you can see exactly how all of the logic works. So what I'm going to do here is I'm going to add a new test case that should create an assistant that has some other assistants connected to it. So let me do that now, and then I'll get back to you once completed. Okay, so here are the tests that I just created. As you can see, it should connect to assistants. And what it does essentially is it just creates a create assistant dummy request. Then it adds a previous assistant that I already created in this test into connected assistant IDs. Then it calls our backend API wrapped function. And then it checks that all of the parameters are as expected. So for example, it checks that the assistant ID is actually in our database inside the connected assistant IDs. And then it also fetches the assistant itself from the OpenAI and checks that this assistant contains a send message tool. So send message tool is one of the core tools in my framework that allows agents to communicate between one another. So any agent that can communicate with another agent must have this tool. Additionally, I think I'm going to need another test, which I'm going to add somewhere at the bottom, which should check that those agents can actually communicate and send messages between one another. So let me quickly work on this now. Awesome. Now we can finally proceed with implementing this logic that I have just created. So the first step will be to go to our backend API and change how assistants are created. So let me open our create assistant endpoint, and here we'll probably need to add a few adjustments. So first of all, we use the factory pattern, and we have this from create assistant request function, which is where like the assistant is created. Honestly, this code is not great. We want to refactor our entire backend again because it initially started as just a widget. So the backend initially was written on TypeScript, but now we also have some Python services because my framework is in Python. So it's not a big deal, but we will definitely refactor it later. Okay, so what I need to do here is also modify the client.createAssistant request. So here we have, I think, a function called createTools, which creates all of the tools for the assistant from the function schemas. And here I think I need to add another function, which is going to be called createSendMessageTool. So what it does here is essentially just fetches all agent names, and then it checks that all agent names are unique, and if not, it throws an error, which is then passed back to the response in the function, and the user can then see that collaborating agent names must be unique. Now what I'm going to do next is I'm going to create the function schema itself. So in my framework, if you use Python, basically this is done for you. It's created programmatically, but here, because we don't have this functionality in TypeScript, we need to manually create the schema. So what I'm going to do is I'm going to go to one of the assistants that I created before using my framework, and I'm just going to copy the send message schema like this. Now let me jump back into the code editor, and then I'm just going to paste it here like that. However, as you can see right now, the schema is fixed. So there needs to be a few adjustments, because in my framework, in order for the agents to communicate properly, they need to know their own descriptions, which means that for this to work properly, what we need to do is, as cursor is hinting me, parse the agent description like this programmatically, and then return an assistant name with the assistant description inside this function definition. Then we also need to change the recipients in a similar way. So instead of using a const, what we need to do is we need to add all of the names of the agents into the enumerator, just like this. So here I'm just going to run the test for creating connected assistants and for creating just a normal assistant to ensure that I didn't break any previous logic in the process. Okay, so as you can see, the test failed. Apparently I forgot to add the type for the send message tool. So let me just do this now and then rerun it. Again, this is why you should always write tests first, because as you can see, there are some things that I forgot to do, like for example, push the connected assistant IDs into the Firestore, into our database after the updates. Finally, the test is passing, and we are successfully creating an assistant and then creating another assistant that has this first assistant connected to it. So now the next step is to adjust our backend logic in Python in order to actually enable this functionality. So our Python backend is running on Cloud Run, and we're using Fast API because Cloud Functions actually don't support streaming. And here, as you can see, we're basically like creating agents using Agencii Swarm framework for each assistant, and then we are pushing them into the Agencii class. But right now, as you can see, it's only a single agent because multi-agent communication is not supported yet. So what we need to do is we need to programmatically generate this Agencii chart, which defines how your agents communicate with one another in my framework, and then add it into this Agencii class. So for example, in order for us to make the CEO agent communicate with the developer, we need to put them into a second level list just like this. So now let's go back into the init Agencii class and try to utilize it. So I'm going to create another helper function, which is going to be called getAgencieChart. Now the first agent is now going to be called main agent, and it's going to be initialized from the original assistant ID. And to initialize other agents, what I'm going to do is I'm going to just iterate all of the collaborating assistants inside the assistant.collaboratingAssistant properties and initialize other agents just like this. So now let's run this function on top here and replace the Agencii chart with the Agencii chart that we just generated. So I think the final step is now to adjust our chat-based class, which is where our event handler is located. And this event handler essentially just handles all of the events from OpenAI, like when a new message is created, when there's a text delta event, and so on. So if you want to learn more about how streaming works in Assistants API and in my framework, make sure to watch another video, which I'm going to attach down below. But the whole idea now is that we need to push the message that the assistant sends to another assistant into our messages in a chat document, and then also push the response from the other assistant so the user can actually see those assistants chatting between one another. So my idea is that we're gonna have, more messages here on the left. So as you can see right now, we're showing this assistant icon and it sends me a message like this, but then there's gonna be just like another assistant down below that can also chat with this assistant on the left. So here's one of the most crucial adjustments in onToolCallDone event, where I'm just basically checking if the send message tool was called by the first assistant, and then I'm taking the message provided by that assistant and sending it back to the front end through our queue using the last message content event, which means that the user will actually see the argument provided by the agent in the message as the message content itself. So this will make more sense once I show it to you on front end, but when working with backend, you just kind of have to imagine it in your own head. So now let's also run the last test in our assistant test, where we are actually checking the communication between two assistants. So I'm gonna add also only here, and then I'm gonna run those 3 tests together. So as you can see now, we have 2 threads in our backend logs. The first thread is between user and test assistant 3, and the second thread between test assistant 3 and the test assistant. So let's see if our tests pass. So unfortunately, it seems like the function name is not send message, right? Because I decided to actually name it as the name of the assistant. So now let me just adjust this test and then rerun it again. Awesome. So as you can see now, all of the tests that I just added are passing, which means that the functionality is basically ready to be deployed. So as you can see now, the test is running on our GitHub Actions and it runs the full test. So we have a lot more than just assistant test. Obviously, we have, I think, in total like 56 different tests that test every single functionality of the application. And because I don't want to run this every time on my computer, it's a lot faster to set up a workflow that will just run this on every commit. And then later on, you can easily see if any tests fail, so you can see exactly where we introduced any bugs. Okay, awesome. So as you can see now, all the tests are finally passing, which means that now I can create a pull request and then assign a task for our front-end developer. So I'm going to create a pull request into staging, which is our branch for QA testing everything. So once we merge into staging, basically we have this like separate URL where we can test the application. And then once we merge it into main, it gets deployed to production. So now I'm gonna add a task for our front-end developer, Vladislav, and just instruct him on how to use this feature and also how to add this new selector component that I imagined earlier. Okay, so here's the task, and after this feature is completed on our staging, I'll get back to you with a short demo. Alright, so we've just finished this feature. Now Vladislav has added this new component on our front end, which allows you to select any other agents that this agent can communicate with and assign tasks to. So let me, for example, connect our Layla agent, who is an AI operations manager, to Leo, who is a business analyst. Now let me just say, for example, how can I improve my business efficiency? Awesome, so as you can see now, Layla uses the send message tool, just like I coded on the backend, and then Leo responds to me instead of Layla. So as you can see now, Leo is responding in the same chat with some business strategies that I can implement right now, and then Layla provides me a short summary of its response. Obviously, this is a very simple example with just 2 agents, but where this can get really powerful is when you connect multiple agents together with a single agent. So for example, you can compile information from multiple sources or virtually add any amount of tools to your agency to handle incredibly complex tasks. So we're probably gonna take a few days to QA test this and then we'll deploy it. However, keep in mind that our platform currently does not have freemium tier, so it's a fully paid platform. However, with this subscription, you also get access to our exclusive school community, where I'm currently hosting 2 Q&A calls a week, which have been incredibly productive. I'm super excited about what our community is building with this product. So if you want to learn from one of the first movers in the space, definitely check it out below. We also have some exclusive playbooks, and the AI Agent Developer Academy, which is my course, should be out by the time you watch this video. Thank you for watching, and don't forget to subscribe.